So we have about 21 participants today. Let's wait for a couple of minutes so that others can join in. And I'm also making some tools ready in the meantime. Hey, so we have 23 participants. It's doesn't okay. Anyway, let's get started. So we have what we have today. Today we have about the SPIM simulator, and you were supposed to uh, install your Mars IDE. So how many of you have done that? Like, or uh, let's see. Is there anyone who haven't done this or wants to explain if there is any problem in using that and so on and so forth?
Professor.
Yes.
There are some people who aren't able to join the Zoom meeting because it's their first class or first time attending the class after adding it.
Oh, really? I thought everyone is already registered and oh, I had trouble joining our call from Zoom. I had to go to there. What happened? Yeah, I don't know. I haven't changed any setting. You already registered for all the sessions, right? And if you already registered for session, then yeah, nothing should happen. Maybe it's a Zoom update, something like that. So Matthew told was asked to register again, get approval. I don't know. So if you register, so if you register, basically, then register for all the sessions. Don't just register for one. Okay, otherwise it will send me. Now what I did, auto approval, I stopped the auto approval. And from now on, I need to go and approve myself if there is any new registration. Maybe that was the reason. I don't know. let's see, I'm just looking at my Zoom session setting. Just hold on. So for this class, I see, oh, okay, oh, okay. I believe that thing that happened. Okay, there were some pending approval. It didn't show me earlier. 33. I hope I see there are 51 approved. So let's see if I have any more. Oh, that's strange. Okay, let me do one thing. Let me turn off the waiting room and admit all. Carter said it is asking me to register almost every lecture. Carter, that may not be true. You can actually register for all the session.
Hi, Professor.
Yes.
My name is Hang Ho, but I asked my friend to send me the link. So my name now appear as my friend's name, Nguyen Nguyen. Because I couldn't join from Canvas, so I asked him to send me the Zoom link. But now my name appear as Nguyen Nguyen. Is that okay?
I don't know what's your case. Can you please send me an email about your...
Sure.
I'm pretty sure you can still rename yourself using the normal methods.
Okay, let me find it. Thank you.
But it's all linked with the emails in it.
So you cannot join from the Zoom, sorry, from the Canvas. You don't have Canvas access. That's what you were saying?
No, we have Canvas, but the Zoom link we cannot access from Canvas. It's asked me for the passcode,
Okay.
and I don't. Yeah, but I couldn't find any passcode on your Canvas.
We were able to get in through putting in manually the room and then putting in the password. But this time when you click on the Zoom link, even if you were pre-registered, I guess for some people, it won't let you register again, or it says that you have to look through all of the registrations over again and that we're waiting on you to accept us. But we were already registered, so I'm not sure.
Huh. That's, yeah, because that's my surprise to me. Like I see there are pending approval from me. I just approved them, looked at the list. And you guys have registered for all the session, right? It is not
Yes.
a single session.
There's no way to only register for one session. You have to register for all the sessions.
Oh, really? Okay.
But it's still asking me to register every single time.
Oh. So is
I did
that
it.
Yeah.
I did it slightly differently today. I clicked on the invitation button in the list of Zoom things, and I just copied the number, and then I used the password from there too. But usually I go through the register thing. So maybe if people can't get in, they could try using that, but it's kind of hard to figure out which number.
Yeah, the invitation is kind of a lot of text. It's confusing to read.
Usually that invitation text is like emailed to us, at least in previous classes I've had.
I looked at the invitation one and I didn't get the right password. Like my password was different.
See what is going on. Okay, I have this setting on registration required, and attendees registered once can attend any of the occurrences. That's what it is. So I'm not sure, like why it are asking for, every time it is asking for a registration. That I'm not sure. Maybe if someone has some ideas, can you please put it on the discussion so that we can resolve it for everyone? Maybe there is something I can do, maybe something others can do. So whoever has a working method to join this session every time seamlessly, can please describe that in a discussion. There is a discussion section, I believe is a class logistic challenges or something like that in the Canvas. Can you please put this on the method that you are following that worked for you?
I think based on the Discord for most of the people when they got in, if they just open the Zoom app and then click on your meeting and then put in the meeting password, they were able to join instead of using an external.
Yeah, this is the only way that you can get in.
Okay.
So Professor, 10 students are in a YouTube. So they put a comment over there. Just I want to let you know, I was over there too, but the 10 students over there, just they're over there.
Oh, okay. So let me just see. Okay. Registrations. Yeah, I'm not seeing anything. All the pending approvals are there. Yeah. Hmm. So how did you guys get the password? Can someone explain?
Okay, so when you have the Zoom. Oh, sorry, it doesn't, hold on, let me unmute. When you have the Zoom page on Canvas, there are two buttons next to each listed meeting time, join and invitation. If you click on invitation, it gives you a big wall of text. And in there is a link to, and there is meeting ID somewhere. That's the same across all platforms. That's like 995, etc. And so you put that, so you click join in Zoom, and then there's a password, which is the one listed under PC, Mac, Linux, iOS, or Android. And that's the password CS47S2F20. And so you use those two things. That's where I get the correct password anyway.
Okay, I hope whoever is in the listening to the YouTube can now access the password and join in.
If it doesn't work on their Zoom, then I can say that the password is CS47S2F20.
Yeah, let them find out. That's okay. So I see there are 51 approved list. Okay, let me just send a message to the YouTube as well.
Professor, I put a password on a chat. If you want to see that, CS47S2F20.
Yeah. Okay.
Just this one for the Mac and PC, not for the iPhone or iPad or Android tablet, if someone want to see that.
Okay. Yeah, so you find out, I think, let me see what there. So you got in, Omid, Ahori, yeah, she's
I'm here.
Reyes, you are in. Yeah, I see. Ethan, are you in? Yeah, I see Ethan. Yeah, I think that's all from there. So yeah, okay. Thank you, Narinder. Let's hope like next time this jitter doesn't come in. And let's start on today's topic. Actually, I need to check one more thing. Just hold on. Okay. Okay. I think that's should solve our problem. Okay. So where were we? Talking about the Mars ID simulator, etc. Is there any question? I didn't see anything on the canvas so far. Let's see. Discussion.
Are we allowed to ask questions about the quiz one?
Let's hold on to that. There are a couple of students who still needs to go through that quiz one. So that's why I'm not opening up the answers as well.
Oh, okay. Yeah. I'll ask after everybody's done.
Yeah. So once everyone is done, I'll open up the answers. Then you can check. And then if you have question, then get back to me.
Okay, sounds cool.
Okay, so
Professor, would you
yes.
be able to go over how to take inputs using the Mars IDE?
Sure, yeah. That is actually one of my plan was. So first, let me bring up the Mars and also share my screen. One. Okay, good. Okay, this is what the Mars editor looks like, right? And if you have not installed it, please install it. We'll be using it throughout this semester, this tool. You need to get familiar with that. And all the upcoming programming assignment, project, etc., are based on this IDE. So the very first assignments and all this discussion, this specific lecture 6 is designed towards get familiar with the Mars and get familiar a little bit with the assembly programs and how you can write it for the MIPS processor. So our target processor is a MIPS. So now, what did we do in our code? Okay, here was the slide for that very first experiment. We can start writing them. Data and just, yeah, I think I can see. Control P. Okay. So this was your program, and let me save it. Maybe desktop, MIPS one. All right, yeah, that's fine. So we write some code. What code it is, like we'll be learning. little bit, okay, on this how to write the code. That's not the important right now. Important is I have the code. How do I run or see the outcome of this? So
We can't see your screen.
am I not sharing? No? Yes?
Professor,
Yeah.
the Mars ID won't install on my computer. It says that it has a virus.
Wow. Is it like Mac or something?
Sorry, Professor. If you're using the Mac, no, it's not a virus. You should go to the setting. Let me show. Let me say. You go to the on the on the left side. Go to the system preferences, and then go to the. Oh my God, I forgot it. Then go to. Oh.
I think if you right click it, it'll give you the option to open it, and then from there you can accept to open it.
Actually, it has a lot of video on the YouTube. You can see that how to deactivate your firewall on your Mac, and then you can run it.
You can just right click and open with Java regardless. You don't have to like turn off your firewall. You can just open it using Java by go to your Finder and
Actually,
then
I am, yeah, exactly. I am running it like running it like this.
yeah, you can like just force open it.
Windows.
Just go to your Finder, right click the application and then run it with Java. Should open.
Yeah. So yeah, all these are good discussion. Can you put it on the discussion board on these challenges and what are the solutions so that everyone be on the same page, please? Okay, yeah, while you guys are figuring out, there would be some way to run this. Let us continue our discussion on this class. So basically, when we are opening this one, had a new program written there, we just click on this assemble and it creates a machine code for you for each of these instructions. And it places some data onto the data segment. So data, this is the data memory part where it stores some data. And on the text segment, it uses like from this address, specific address, it stores the machine code for this. And then what you do, you simply run this thing. And it's a simple hello world program, which does not print hello world, but it prints like the answer is equals 5. And what it does really, it has this code, and let me try to explain that in detail, because in like I see, I find often you guys are lost in what is the syscall and how to use it. Okay, let me try to explain that part. Okay, so let me copy this over the Jamboard. Okay. This will do. Okay. And we also want to look at this table. Okay. So first of all, syscall is not a MIPS provided fundamental operation. This is more like a simulator provide an ID Mars and SPIM. Mars is the IDE, SPIM is the simulator of the processor MIPS. So this IDE Mars provides, the SPIM simulator provides this facility of syscall to provide some sort of your operating system like functionality, like for the IOs, manipulations, and mainly for the IOs. And then it has this file read and file write, file open and close, exit, etc. Those kind of system functionality it provides. Now, how it works, this guy, syscall, like, first of all, let us little bit review on the syscall code. See, this is the syscall code, something like 000C as a machine code level. This is not an valid MIPS instruction, but this machine code, if the simulator receives, it knows it's trying to use a syscall, which is a simulator provided feature. So once it receives this machine code, what happens is, let's say this syscall, it looks at the value of $V0. Okay, looks at that value. This syscall looks at this V0. Now at this specific line, V0 is 4. Why? Because of this line. That is load immediate V0. 4 means load the value of 4 onto the V0 register. Okay, or the variable. Right now you don't know about the register and everything, just call it this is a some variable. Okay, we'll talk about register in the next class. So we load this value 4 onto the V0. So that's what it is getting. Now V0 in this syscall table with a 4 is a print string function. Okay, so that's how your syscall at this point knows it has to do a print string. Now a string is what? String in this program we defined here. And the memory, in the memory, it is nothing but a bunch of ASCII codes, right? Like D, H, E, space, and star, something like that. It is actually stored byte by byte. These are byte, or you can say it is a character ASCII code. Code is stored in the memory. And print string, what it does, it takes the beginning of the string, that is the beginning address or start address of the string. And this start address is stored in A0. You see in the table, it says that argument is A0 equal to string. Here it really means the starting address of the string. Okay, so in the A0 it expect that, and what we are doing here, we are loading A0. This is a load address, LA load address. This is, by the way, a pseudo instruction. It loads the address corresponding to the label str into the A0 register. So your A0 is really address of label str in this program. Okay, so this str is basically laying down your whole string. That's the A0 value is the address of the start point of that string. In fact, if you turn on the ASCII button here, you see It's a little bit odd to read this memory layout, but it is really like THE space ANSWER answer space IS space equals and a termination character null, which is 0. So your character is really laid down in the memory, but it is always like a bit pattern. So the point is that from computer perspective, there is nothing called character or text or anything like that. Everything is a value, everything is bit pattern. It's only depending on the user program, user intention on how to use that bit pattern, whether to use that as a value, whether to use that as a text character. It really depends on the software program. From the hardware point of view, it is always some bit pattern. Questions so far? All right. So now, what happens here now on the syscall? This goes and access the value of V0, sees the code is 4, which is belongs to print character, print string. On the print string, that specific method or routine or subroutine, whatever you want to think that way, that expect your address of the string at the argument register A0. So that's what it accesses. So it calls this system function, you can say, and that system function in turn access the A0 registered value and print that string from there. Okay. Now on to the next syscall. What happens here? So before we go into what happens here, let's look at what happens before that. Okay, one thing which happens, load immediate V0 as 1 and then load immediate A0 as 5. Now syscall. Now syscall does what? It first check V0 content. So now it sees V0 is 1, which belongs to a system called code from the table. If you see, it's a print integer. An argument is an integer value stored in a register A0 or variable A0. Okay, so it basically, this is a print integer. Syscall calls this subroutine or function, which in turn access A0 and the value as it is printed on the screen. And then next syscall is here. Before that, we set up V0 as 10, and this V0 10 is exit, system call code for the exit or the program termination. So this syscall goes, when you are using this syscall at this point, this syscall goes and check the current value stored under V0, which is 10, which is according to the table, it is exit. So it performs the exit function. So that means the usage pattern is this. Set $V0 to system call code. And what is that called code would be coming from this table, right? And then set argument, if any, So you see for this case, these two cases, there was an argument involved, A0, but this case, the other case, this one does not involve an argument. It is just a system call code itself. So once you are done, then call syscall from your program. Okay, so that's what the syscall functionality is. Question? Okay. Now, going to the Carter question, how the reading would happen in that case, right? So let's discuss that one. So let's see, I want to read an integer, right? So what we need to do first, remember, we need to do first, set the V0 to the system call code, then they set the argument if there is any, and call syscall. So according to these steps, for reading an integer would be like this one, right? System call code 5. So that means we are supposed to do something like first set, let me change the color. Okay. Load immediate $V0 5. And now let's ask, is there an argument involved there? No, we don't need to do anything then. Then do a syscall. Okay. Now, what will happen to this syscall code? So from here, we are setting up $V0 as 5. So this syscall will see, okay, this is 5, that means read integer, it will call for that one. And that specific routine actually wait for you to type in some number on the keyboard. You hit the enter, and that value will be stored in the V0. So that value will be stored in the V0. So this calls your readint method, and that guy actually changed the V0 itself with the number you type in. So you type some number, example, let's say you type 10, 10 and hit enter in that case, right? So what it will do, it will basically change the V0 value and place a 10 there. So after this, at this point, your V0 is going to contain 10 in this case. Like, let's say you typed in 10. So at this point, what you can do, like use that value for your purpose from the V0 itself. For example, let's say you want to capture that value in a register, let's say T0. So what you can do, you can actually do something like this. Move, by the way, this is also a pseudo instruction, T0, V0. So this specific one will do this operation, T0 equal to V0 operation, right? We can try this. Let's try it. If you don't have any question, let's see if you have a question so far.
I'd like to see move work because I can't get it to work on my Mars.
Let's see. So I want to, let's say, at this point, I want to do this thing, li $v0 as 5 syscall, let's say move $t0 $v0. Okay. And let's make us breakpoint. Stop here. Okay. So we run. Okay, so far execution paused at the breakpoint. So it is coming here. So what we can do here is basically step 1. Okay, so V0 is now 5. Look at this code. It turned green. It's 5. Now we are doing syscall. Now see, there is a cursor prompted right there. So let's type in 10. Enter. Now it moves to the next one. Now see the V0 value, it changed to A, which is hex for 10, right? And now let's do one more step. See the T0 now gets the value of A. So move does work seamlessly.
Interesting.
Yeah, try once more and see what's the problem coming up. Okay, any other question so far on this syscall usage?
Would the syscalls be macros or methods?
Syscall is neither macros nor method. It's basically simulator provided feature. It is not really, yeah, I don't say there's a macro. Macro is basically uses basic instruction, MIPS instruction under the hood, similar to the pseudo instruction. Syscall does neither of. Basically, a simulator provided feature. It just, like at this point, when it comes to your simulation comes to like a syscall point like this syscall, right? At this point, it basically does not send anything to the processor, but it manipulates its own thing.
Okay, got it.
Okay. So let's take then 5-minute break and we'll be back at 6:50. Okay, 6:50. Let's get back to where we were. So I believe you have one programming assignment coming up. Let me just check. Just hold on. Where is that? Assignments. Okay, this programming assignment, right? Share. Okay, so these programming assignments is coming up and it is due on 14, September 14, which is tonight? No, oh, sorry, no, September 17th. My bad, not September 16th. September 16, that's the due date. September 16, 11:59 p.m. That's the first programming assignment. What I'd like to you guys to do here at this point is let's go to the break room. I pre-assigned with your study groups on the break room side. Let's see if that's working fine. And also, basically what you'll do in the break room, discuss this programming assignment among yourself. Like, let's take like maybe about 10 minutes to do so. And let's see what comes up, okay? How do I do the break room? Breakout rooms, okay, reassigned. Options, 10 minutes, maybe 30 seconds. Okay, I'm opening all the breakout rooms for you. Okay, I think Michael, I need to assign you somewhere, right?
Yeah.
Okay, yeah, I know which room you are in. So you got registered back?
Yeah.
Okay, great. I know which room to place you. Just hold on, let me bring up my spreadsheet. Michael, you should be.
Hello?
Hello?
There's a problem. The assignment's locked until 7:15, so we can't discuss about the assignment. Like we cannot see the instructions.
Oh, okay. Let me unlock this. Just hold on.
Yeah. Thank you.
Okay, Michael, I'm sending you to room number 11. Okay, that's your study group is. So I realized that that assignment was not open, and I probably like 5 or 7 minutes back I opened that up. So could you guys access that assignment?
I could.
Yeah.
Okay, so it seems easy, difficult.
Seems easy. I
What
guess.
is that? What does STDIO stand for?
Standard input output, which is like your keyboard is the standard in, and your terminal is the standard out.
And the built-in terminal in Mars is the output, right?
Exactly. So let me share my screen once more. And assignments. Yeah, so read an integer value from the stdio. So remember, like in this program, like let's rerun this guy. So now it is okay. Stop. Let's make a breakpoint right here where we are trying to see how the input works, right? So we run, stop there, step. Now at this point, see there is a cursor coming up on this Mars IO, and there we are typing some values, let's say 5.
You need to share your screen.
Oh, I didn't, okay. Oh, sorry, share. Now can you see? Yeah.
Yes.
Right. So let's rerun this. Okay. So clear. Okay. Okay. Complete. Run. Step. Now at this point, this syscall, this yellow highlighted syscall will have that input from the standard IO stream. Okay, which is basically Mars provided run IO terminal for you. So once you step there, see there is a cursor appeared on the run. Here it is actually waiting for your input, like you type in 1.5, enter. Then it moves to the next instruction, which 15 is a F, V0 is F. Now it basically moves that value to the T0, which is F. Is that clear? That's the STDIO mean, standard input output.
I have a question.
Yeah.
So in the lecture, you said that you can really harm the computer system if you're coding directly on it and running assembly code directly from your machine.
Yep.
So like, what would be an example? I mean, like, could you get caught in a loop of instructions? Is that something that would happen, or?
So you can override some of the system assumed standard information stored in the memory. That's one way to see it. So,
okay.
So through the assembly program, you can actually write in any location in the memories, and you can treat any data as anything. Like you can treat data as an executable, so on and so forth. So that way you can actually unknowingly overriding some of the system, what system assumes so to be some standard information it stores and retains for the bookkeeping purpose for entire system to run okay smoothly. You can step into that, override that, and get make the system crazy in a very nutshell.
Okay, thank you.
So in fact, these viruses, those things, they exploit all these things, basically. Trojan horses. Okay, so yeah. Okay, all right. So one more thing before we close today. Remember, I was telling that LI and LA and move, these are all pseudo instruction. Why you can see this? Like you wrote LI, but it translated into the basic code. See, there is a column called basic, source and basic. So this basic actually gives you how the assembler, this Mars ID assembler, actually translate that LI into some basic code. So it uses add IU $to $0 this thing. So you can actually write this code itself to have the same effect or same program. But this actually saves you typing, like LI $V04 actually saves typing. And instead of if you are typing add IU, some to register, some immediate value, etc. Another example is the LA. See, the LA is actually performed by two operations, Louis and RI. So this is a composite instruction which is not supported by the MIPS, but assembler translate the LA into two basic instruction. So that's what the pseudo instruction is. Same for the move. Instead of writing move, you can actually write this assembly. Add unsigned $8 or $T0, $0, $2. Next class, you'll see this $0, which is this 0 register. This is a constant for the MIPS processor. You cannot override its value. It is always 0. So it is used in terms of this type of coding. Like if we want to just simply move around the data from one register to another register, you basically apply add immediate unsigned with that, add that to the $0 with the value, sorry, this one, adding $T0, add $0 with the V0, $V0. That way, basically, you are adding up 0 on top of $V0 and assigning to the T0. So either this code or that code works fine, but this is more like a pseudocode. So you just pay attention to that, which one is pseudocode and which one is not. One more thing, take this thing, help, okay? This help will actually give you a lot of ideas of what you can use from the basic instruction perspective. It explains what is what. It has like, probably we'll use only some of them, not all of them, okay, not all of them. And then it also gives you the list of the extended or pseudo instructions. All the pseudo instruction, what does it mean, etc. You can get a help from this page. So please use this page like often if you lost and if you want to know more about what you can use in your program, you can use basic instruction or pseudo instruction, doesn't matter. You use something, right? Okay. And it talks about directives. We'll talk about this later in the classes also down the line, 3-4 lecture. It talks about the syscall, the table I showed you in the slide. It basically, it has more detail and which is more related to the Mars. Okay, this syscall is related to the Mars, but it's mostly compatible with the table I showed you. So you can use this table as well. So let's not go about the macros and exception, but you can read later on this part. Macros, we talked about that. You can read more about what is macro, how to use it, etc. So this page is really, really great page to explore. Help, or you can hit the F1. That will give you a lot of insight into the different instruction that you can use in the Mars. Question? All right then. So that it for today, and we'll all see you on next Wednesday.
Okay,
Thank
thank
you.
you.
Okay, thank you.
Thank you.